Okay, YouTube, in this video and my next couple of videos here, we're going to focus on factoring polynomials completely. And so in the past, we've talked about factoring polynomials and specifically quadratic polynomials or polynomials of degree 2. But what we're going to see is we're going to end up with polynomials. We say, you can also factor polynomials with a degree greater than 2. We're going to start to see, third, fourth, fifth degree polynomials, maybe ninth degree polynomials. We're going to have to factor them completely. So what we mean by factoring completely using techniques that we've learned already is that a factorable polynomial with integer coefficients is said to be factored completely if it's written as the product of unfactorable polynomials with integer coefficients. So now this integer coefficients, I'm not going to get banana shape immediately about this. What I want you to see is this. It's written as a product of unfactorable polynomials. So what we're going to do is we're basically going to take this original polynomial, we'll just call it some function of x here, and we're going to split it up and we're going to write it as the product of a bunch of, say, factors that it splits up into. And when you get down to factors that you can no longer factor any longer, then we say that this is completely factored. So in terms of completely factored, I'm going to look at these three polynomials with everybody here. But basically, what you're going to see a lot of the time is higher degree polynomials. I mean, this should happen no matter what you're factoring. But most especially with higher degree polynomials, you look for a GCF first. So maybe make a little note here. Always check for the GCF. Always check for GCF first. Let's say is number one. And then number two is just use conventional factoring patterns. When I say conventional factoring patterns, I really mean like differences of squares, sums and differences of cubes we're going to see this afternoon, and then we're also going to see grouping. But anyways, we have different factoring methods that we can use here. So let's look at number one here. We say they all have an x in common. Taking out that x, we have x squared minus 7x to the first, just plus 10. And so what I want you to understand is that we just have to keep going if we can split this up. So the thing that's going to happen here is that this trinomial is going to factor, and in this case into x minus 2 and x minus 5. But we just need to bring down this x right here. All we did was essentially rewrite this as the product of three factors here. So we say that the original polynomial in a factored form is this right here, and it's completely factored because I can no longer split these up. So on number 2 here, I noticed that 3 is like a factor of each of the coefficients, and also they can each give 5 n's. So we're going to take out 3n to the fifth, and writing what we have left over after we take out this GCF, we'd have n to the second minus, and this would be a 25 if we divide it by 3n to the fifth. So now this thing right here, this is a difference of two squares. So what we know about differences of squares is that they factor into what we call conjugate pairs. So one of these is n plus 5, the other one is n minus 5. Those are our conjugates. And so we can't factor any further than this. We'd say that this is the completely factored form of the original polynomial. And then last but not least, this number 3 here. Looking through, it looks like 8 is a factor of each of these terms, and also m to the third. They can each give 3 m's. So we say 8m to the third. Sorry for that 3 right there. We say m squared. This would be minus 2m now to the first plus 1, I suppose. It'd just be a 1. And then this thing right here, if you don't recognize that it's a perfect square trinomial, that's okay. But I will say that it does indeed factor down into this. We'd say m minus 1. You can check this. It'd be m minus 1, m minus 1. But we'd say that this is the completely factored form. We can certainly write this as m minus 1, m minus 1 without scrutiny. That's a totally fair thing to do. But this is the completely factored form. Cheers.